pathway to, let me just also show you my face, on a common pathway towards sustainability and digitalization. Let me just quickly run you past the conditions of our this morning's session. I hope you had a nice weekend. We suggest to all of you that you please, on entry, mute your mic as well as turn off your video to conserve bandwidth. We will have 6 presentations this morning, and after every presentation you will have the possibility to either raise your hand with the WebEx functionality on the right-hand side, or you type in the chat hand, and then we will consider you in giving you the floor. That's a point for asking a question. And for the presenters, I would like to suggest to you that if you're presenting, maybe you open up your video if you like. If you don't, then you please close it down so we can all see you maybe a little bit more interacting with us on the screen if you prefer that way. That's up to you. And with that one, I'm the only thing what I'm missing is from Vlado. If you could make me presenter so I can share the screens, then that would be really helpful for everyone. Vlado, could you do that?
Absolutely. Good morning also from my side. It's Vlado from GRC. Just in addition, the meeting or our session will be recorded, and the recording we will post it later on the Inspire YouTube channel. So by saying this, I will give the floor to Hannes as a presenter.
Okay,
and Hannes, the floor is yours.
Okay, thank you, Vlado. And again, repeat myself, please turn off your video. I see Shivam has still his video on. If you would be so kind to turn off your video, then we all have a better video conference experience that has been proven. So all the questions in the chat, and we will address them after every point. And with that one, Pier Giorgio, are you ready to go? I will load your presentation in a second. Here we are. Sorry, I'm a little bit slow this morning still. So, and I need to go here. Hello, hello again.
Yeah, maybe I can just start to say good morning to everybody. I hope you can hear me.
Yes, we can hear you loud and clearly, Pier Giorgio. Here's your slide. I hope you can all see it.
At least I can see it, so I can start. Okay. Good morning, everybody. It's a pleasure for me to give you a status and outlook on the work UNGGM Europe is conducting at the moment, particularly the working group on data integration. My name is Pier Giorgio Zacchedu, and I'm the chair of this working group. And this presentation has been jointly prepared by some colleagues in the working group. Next slide, please. This slide gives you an indication of the countries who are cooperating in this working group. Some members are online. I've seen that in the list, which is nice. And you can see that we have a very good and strong link between national mapping and cadastral agencies in countries, as well as statistical institutes. In some countries, both organizations are contributing and cooperating. In some countries, only the statistics or only the mapping agency is cooperating. From the Commission side, we have Eurostat, the Joint Research Center, as well as the European Environment Agency as a member of the group. Next slide, please. Today, I would like to share with you the deliverables we have published last year, so I will refer to the work plan 2017 to 2019 briefly, and then the main focus will be put on the new work plan which we started last year. Next slide, please. So with regard to the work plan 2017-2019, we conducted and published some documents, deliverables with regard to data integration. We conducted a very comprehensive poll with a questionnaire and asked the statistical offices and the mapping agencies questions on data integration, the status and the current activities. And we have then asked both organizations also to, if possible, to provide us with a coordinated answer of this questionnaire. That is published on the UNGGM website, GGM Europe website, if you are interested, and gives you a good overview on the status in several countries in Europe. The questionnaire and the assessment was the rationale for a policy outreach paper. We wanted to address the decision makers and the politicians with a policy paper, and that has been also prepared by the working group, and it is published as a Eurostat publication. The link is included on this slide, and it provides you with recommendations for a better data integration and more efficiency in data integration. And as a link to this policy paper, we have also published a leaflet with some more examples on data integration. And also this leaflet is an Eurostat publication. Next slide, please. In the work plan until last year, we have also invested some time in sustainable development goal indicators. And mainly we have focused on what geospatial information can and shall be used for specific indicators. And we have selected 4 indicators in that analysis. I will not go into detail here, but these indicators were analyzed, and not only the geospatial information has been indicated to be used for these indicators on a European level as well as on a national level, but also the methodology proposed by the United Nations has been analyzed, and also recommendations for a better methodology have been collected and have been submitted to the United Nations. Next slide, please. All this has been summarized and compiled in a report which was published as well, and you can get this report from the UNGGM Europe website. Again, it includes also recommendations for the data as well as for the methodology. Next slide, please. Coming to the new work plan, we have had a kickoff meeting in October last year, and with regard to the work plan 2019-2022, next slide, please. We have agreed that we will further analyze SDG indicators, probably with a focus on environmental issues, and that's very good that the European Environment Agency has joined the working group to shape this task. In parallel to the SDG indicators, we have also another task stream on data integration methods to enhance and promote further data integration in general. And we have also been assigned the task as an advisory group to data integration activities in general for the United Nations, as well as for the Commission. For example, the Geostat 4 project. Eurostat is funding for this project, as we did in the past for Geostat 3. This working group will also serve as an advisory group. Next slide, please. Yeah, this gives you, for the first task stream, SDG indicator analysis, a brief overview of the lines of work and the expected outputs. So we will mainly benchmark pan-European data sources, and we will also evaluate and analyze the integration of pan-European data sources jointly and together with national data sources. Outputs will be technical and methodological documents, and also, again, some flyers and leaflets illustrating the approaches analyzed. Next slide, please. A very good approach is that we will, as I said, include the European Environment Agency and for the first time also the SDG working group of the European Statistical System. And that's very good that we have a cooperation agreement with this working group in order to really also exchange the views and ideas with Eurostat and the European Statistical System in that sense. And of course also with the United Nations Economic Commission for Europe, but that has been done also in the past. Next slide, please. Yeah, here is the current list of SDG indicators which we have agreed upon to start the analysis. I can offer, and this is a kind invitation to you, if you are working on these indicators or if you are interested in getting more insights in these indicators for the use of geospatial information in combination with statistics, then please get in touch with us and we will provide you with further information. Next slide, please. The second task stream, as I briefly said, is on data integration methods. So besides the SDG indicators, also data integration methods will be analyzed by this working group. And we will focus on methods like table joining service, linked data, or geocoding in general. We will evaluate also the links to the global statistical geospatial framework and the work that has been done for the European view on that. And as I said, we have a strong connection also with the Geostat 4 project. So to avoid an overlap and a duplication of work, we will exchange ideas on that. And we will provide a report on the pros and cons on each method collected, as well as provide again recommendations to that. So with regard to this task stream, if you are interested, please provide us with information and other methods you might identify to be very important. Next slide, please. Yeah, this is my last slide. So again, this was a brief overview on the work on UNGGM Europe and the working group on data integration. And you are all invited to join us and to provide us with information. And if you are interested in our information, the UNGGM Europe website provides you with all the reports and the next steps. Thank you very much.
Thank you, Pier Giorgio, for this interesting presentation, and thank you for keeping it so much in time. Any question to Pier Giorgio? I see something in the chat. Could you please make an example of a pan-European data source which is not derived from national data source? Pier Giorgio, do you want to answer that question?
Could you repeat the question? A pan-European data set?
Yeah. Can you please make an example of a pan-European data source which is not derived from national data sources? I can make one.
Yeah, then please go ahead.
No, I mean, you can also go ahead. I mean, just because I saw this chat question maybe a minute before, so I take the floor and give it afterwards to you.
Yeah.
I have one example. If we have data sets derived from satellite, from Earth observation, talk about air quality, NOx, something like that, which is grid-based and derived from Earth observation. That's certainly not derived from pan-European, from national data sources. Still, that needs to be validated with ground truth based on national data. But maybe Pier Giorgio has another example.
Well, we are investing some time, all national mapping agencies, and also with regard to a European use case to see how authoritative data can be combined with open data sources as well. So I think we have to face in future the situation that for certain use cases and certain applications, we have to always look for the best combination of data. And so at the moment, apart from satellite images, that was a very good example from Hannes, I have not a clear example where we have not used authoritative data for that, but a good combination. I think that is the future.
Okay, and Pier Giorgio, you have a second question. From the chat, Shivan is asking, for analysis of geostatistic at the indicator level, is the analysis based on some frameworks and at application level or general? Shivan, you want to rephrase that question or Pier Giorgio, you want to answer that question?
Well, I can provide a general answer, and then Shivan might say if he's satisfied with that, because with regard to the SDG indicators, there is a so-called metadata which provides you with the information about the method and the data to be used to calculate this indicator. As I said, when we get into the analysis, then sometimes the definition is not clear, and you have to make some decisions. Sometimes the data is available for a regional analysis for Europe, for example, but on a country level, there is no data available. And then you have to think about open data sources, for example. So each country has to take its own decisions. And we are trying to give an overview and also to provide cooperation in Europe with regard to the indicator calculation.
Okay, thank you. Pier Giorgio, Shivam, is that good for you as an answer? Yes, thanks, super. So now, just to give you a little bit brief background on that one, how we have actually, what's the flow of the presentation, because we have started really from the high level, from UNGM Europe. Let's go down to member state level, and we will drill down to Statistics Austria work, financed in a Eurostat grant, merging statistics and geoinformation, where we learn something about machine learning based on poverty mapping for Austria. And then we go down further into work from ELISA, and then more in SDMX, and how do we disseminate statistical data, while we close the session with a presentation by Kati Slide about API for Inspire. So, Matthias, are you online? Do you would like to present yourself, or should I share your slides for you? Matthias, can you increase your volume of your mic a little bit?
Can you hear me better now?
Yes, Matthias, that's super. Thank you.
Okay, because I'm sitting in the same room with my colleague Johannes Gussenbauer, who did actually all the programming behind what I'm going to present. And I wanted him to listen, but he can listen to me in the room anyway. So I'd be grateful if you can show the slides.
Okay. Dan, yeah, you go.
This is a project Hannes has already introduced, funded by Eurostat in the Emerging Statistics and Geospatial Information Grant. It's a collaborative project, and could you please go on to the next slide? It's a learning exercise, and this quote of Gary Kasparov just shows sort of the philosophy. We explored ways to produce statistical estimates using artificial intelligence algorithms. And we are in an early learning stage. But this quote by Gary Kasparov, who was the first human chess player who was defeated by a machine, just tells us that at some point machines are going to take over, and we should be prepared for that and work together to make best possible use of the machines. So can you go on, please, to the next slide? The objectives of this project was to learn, as I said, to learn working together within Statistics Austria. We have put together at the beginning it was 4 organizational units, very different organizational units, methodology, geospatial information, and the social statistics department. And at the beginning there was also an analysis unit. They worked together to produce what I'm going to show you now. The idea was, of course, to integrate geospatial information and sample survey data. More specifically, we were interested in indicators on sustainable development goals. Mainly this is about poverty, as you will see later. And we had a specific objective to explore how machine learning would work to improve, to enhance the geospatial resolution of our estimates. So we work with sample data, which is limited to perhaps 6,000 households, and you can all imagine that this doesn't allow for very detailed geospatial resolution. And we would like to enhance the resolution by using machine learning and a number of auxiliary data sources. So, as I said, this is all about disaggregating the Sustainable Development Goal indicators. You know, there are several hundreds of them. We only looked at a few of them. This project was intended from the beginning as a proof of concept. We wanted to show poverty maps which used sample information as well as machine learning algorithms. And of course, we were interested to see whether this could be generalized to other SDG indicators. So next slide, please. The context of this is, as I said, the Sustainable Development Goals. You're probably aware, 17 different goals and a huge number of indicators. Many of those, especially on poverty, health, or education, are based on sample surveys. So there's a huge need for disaggregating these indicators in a more enhanced geographical resolution. The problem is that sample size is usually not sufficient, and we, and the social statistics department, we also have very little experience, generally speaking, with GIS. So we're a little bit aliens to this community of Inspire and GIS and so on. So that was a huge learning effort for us. The philosophy is to borrow strength from auxiliary information. So we have things that are, for example, if we speak about poverty, which are correlated with poverty, and we use this information to enhance the geospatial disaggregation. And of course, the ultimate idea would be to create a machine that will do the job in the future for us. So to automatize the geospatial estimation of sample-based indicators. Next slide, please. We have only looked, we have identified 3 indicators, 3 Sustainable Development Goals where we could produce such estimates. These relate to poverty, education, and health. I will mainly focus on the poverty indicator. You're probably familiar with that one. So you look at households which have a household income below 60% of the median. This is defined as poverty, at risk of poverty rate. There is also Europe 2020 target group indicator, which combines income and non-income characteristics to define a target group for the 2020 strategy. And one of those is the severe material deprivation indicator. For all 3 poverty indicators, we came up with machine learning-based estimates. We also looked at the lifelong learning indicator and subjectively bad health indicator derived from UCL. The learning indicator, the educational indicator was based on the LFS, so you can see we did not only use the SILC. For those of you who are not familiar, SILC stands for Statistics of Income and Living Conditions, and it's the main source for estimating poverty. It comprises 6,000 households in Austria, a few hundred thousand over Europe. Of course, that is a bit small for very detailed geospatial resolution. Next slide, please. So the idea is to match auxiliary information with sample information. So we use as auxiliaries register data on income. So we have a lot of tax records, and you will see that is a very important auxiliary information, of course. And the EU-SILC itself draws heavily on the register data. And we use geodata that we have available. For example, we have accessibility statistics produced that we use as predictors of poverty. So what we did, we trained algorithms using the SILC sample data. So the algorithm, the machine had to guess whether people are poor or not, depending on information outside the sample and inside the sample. And the main problem here is that it's not a big deal to do this for a sample. So the machines can be trained to exactly predict sample results. But it's very difficult to get it to prevent overfitting so that you can also make reasonable estimates out of sample. And the main product is maps which are based on synthetic data. So it's not the SILC sample data, but it's made up for each individual in the population. We have an estimate of whether a person is poor or not. Next slide, please. So this is a bit technical, so if there are any questions, my colleague sits next to me. We tested several approaches using R, or the R package, to make our predictions. The one that proved most useful is random forest. It's easy, fast, it's reliable, doesn't require too many IT resources. But we also explored other approaches, notably neural networks, that is a bit more technical and requires a lot of computing power, which is, I'm afraid, not sufficiently provided at Statistics Austria, so we couldn't set up a robust framework for neural networks. We have made some estimates, but we deserve further investigation. So that we avoid the overfitting that I spoke about before, we did a validation exercise. So we train on a training sample. The algorithm is provided with a training sample, but we validate that against out-of-sample predictions actually taken from inside the sample. So 80% of the sample are used for training, 20% are then used to make the predictions. And when the predictions are good in the sample that was not available to the algorithm that we think is a good one. The machine learning, what it does, it optimizes. So it finds the best solution to make those predictions. What we can do then, once we have established this model, so it's a bit different than econometric modeling, where we think a lot about theory and the causal relationships. Here we don't do anything like that. So we just plug in a lot of data. We let the algorithm find the best guess, and then we use these guesses, we save these guesses, and we use them to make out-of-sample predictions. And then we use register information for all individuals in the population. And then what we have is an individual level estimate of poverty or other indicators that we can aggregate to any possible level. So raster or enumeration areas or other regional spatial entities. Next slide, please. What is essential is to understand the quality of those estimates. We are, for us, it's a bit going into a new uncharted territory. So we are not like with regression, we know the R-square is good, or other indicators show me how good the model fits. Here we have a slightly more difficult problem. Basically, it's around counting the number of correct predictions. So we can make certain transformations of that. They are called accuracy, specificity, or if you are familiar, area under the curve. These are indicators which tell us how well we can predict the true state. We have assessed different specifications of models, so where we only use the register informations that we call frame variables because they are in the sampling frame. We have added geoinformation, we have added registers, special registers, so not the frame variables that used for sampling, but more domain-specific registers on income, for example, and we have the full specification. We try to assess which is the best. Next slide, please. And this is maybe the essential outcome of this in terms of the substance or the method. You see different approaches. Each of those figures represent one approach. What you see on the vertical axis is accuracy, is one of the parameters of how well the model fits. And you see a group of approaches to the left, which are low, and a group of approaches to the right, which is high, meaning that are the better approaches. And you have these are clustered into 4 groups. The first column is the frame predictions, the second is frame plus geoinformation, the third is registers, specific registers, and then the full model. And what you can see is once you see one gap in the middle, which relates to the adding of register information income. On the other hand, you don't see much difference between those figures within each group. That is the method effect. So whatever we use, we have compared here the random forest and, for example, the support vector machines or the neural networks. You see very little difference between the methods, but a huge difference what the auxiliary information is used. So what we can learn is what is confirmed here is the usual saying, rubbish in, rubbish out. When we have good data, we make good predictions. What we also can learn is that it may not be so important to play around with the methods, because the differences between methods is negligible possibly. Next slide, please. What we did on top of these accuracy predictions, and I would say that is still a field for discussions, we know certain results from the sample for certain groups. So we compare group estimates taken from the sample with the group predictions from our synthetic data. We also made validation with external data on social assistance recipients and so on. So we did a lot of validation independently from this cross-validation exercise that I just explained before. Next slide, please. To give an indication, we have here plotted NUTS 3 estimates that we produce with our machine learning algorithm, and we plot them against the 3-year average taken from sample data. You see that they align nicely around a diagonal, and the bubbles are proportional to the size. So you see this, the smaller regions are further away from diagonal, which means they are less well predicted, but they may be within the standard error. So you see, generally speaking, that is a good approximation. Next slide, please. This is a similar display, which doesn't show regions, but groups, social groups, and you also see that they are close to the diagonal, which means they are consistent. 3-year average gives approximately the same result as our machine learning prediction. Next slide, please. We must be very cautious about using this data. So we looked first at the coherence with already published data. This is going to be published as, if it's going to be published, is still a discussion going on here. If we do it, it has to make sure that we don't contradict the official statistics from usage. So we made the data, we adjusted the data such that 3-year averages for NUTS 2 level are exactly the same as our machine learning predictions. We did the smoothing, so to avoid sharp contrast between neighboring enumeration areas, we have taken an average of neighboring enumeration areas, so that this is a smoothing of the estimates. We only will publish group results, so not to the decimal place exact predictions, but we will only group areas with very low, medium, high, or very high propensity of poverty or other indicators. So we have more coarse representation of the results. And that is very important. We also have filtering rules established. So if results are relying on a very small number of observations, or few people live in this area, we don't publish. And we also have a rule related to the confidence interval that we have estimated. Next slide, please. Of course, next, please. We are very much concerned about disseminating this. As I said, we have had consultations going on with regional statistical offices and so on. The essential point is we have prepared an atlas application, an interactive one. Is not yet publicly accessible. The crucial thing is the circle in the left corner, which reads experimental statistics, so that we can make clear that this is not the official result. That is the major challenge. If we didn't have this problem, that there can be implausible predictions, we would have already published long ago. But now, tomorrow we'll have another meeting with our Director General to see how we proceed with that. This is the general picture. Let's go to the more detailed to see what is possible with this approach. We have here 500-meter raster data, so you can have a very, very detailed resolution. This is the capital of Upper Austria, where we see regions with very high propensities of poverty in red, and the other colors show you in blue. You see the lowest propensities, so you see some concentrations, and you see the gray ones are suppressed cells. So there we have our criteria that we filter out the information. That is very important because we also get feedback from users that there may be implausible values. So we have our rules established, so to make sure that we only publish what we can justify. Next slide, please, just to give an image. This is our capital, Vienna, and you see certain districts of the city which are having much higher propensity to poverty. So this is district level resolution, just to show you that we can go through different levels of resolution. What may be a bit awkward for users is in the center, in the middle, you have the inner district with exceptionally high property prices, and still you find an above Austrian average poverty rate. So this is an example of the more implausible results that may have to do with weaknesses in the register data that we use as auxiliary information. If there are a lot of people who don't have register information, our algorithms get really greedy to predict persons with low income as poor, because usually that means they are poor. But in the case of persons who rely on capital income or self-employed, where we don't have much registered information, this is going to be false. So we have a lot of implausibility still in the data. So next and last slide. To summarize, we had a great institutional learning impact. So we worked together very well. We acquired a common language, geoinformation, social statistics, and methods, which I think will be very fruitful for the future. We have a huge challenge ahead, which means disseminating experimental statistics. Eurostar has a section on the website. We've also developed a logo for that, but that needs to be coordinated across. There's still some work to be done to coordinate across organizational units. The problem that we face here is specifically is that all estimates have some political implications, and if they are not plausible, they can create a lot of discussion and debate, and possibly, potentially discredit our official statistics. So that's something we really want to avoid. If you've got any ideas, thank you very much. So, as an outlook, I think, as I showed in the beginning with the quote by Gary Kasparov, at present we may think that our human estimates for regional dispersions of poverty and other social phenomena may be superior to the machine learning, but that is very likely to change. So we are just at the start. At some point, machines may take over. People could not imagine that would happen with chess or Go or other very complex games. We are very far already in this domain. For the geospatial estimation, I think we still can learn a lot, and we should continue to learn so that there is the best possible use of our data. So I think with that, I can conclude and be grateful for your discussion and comments. Thank you.
Thank you very much. Matthias, any comments from the floor? Let me just stop sharing, because now anyone has a question, wants to raise a hand. I don't see any raised hand. Anyone else? Go away. No, then I will, due to time, I will move ourselves forward, sorry, and we will move towards our colleagues from GRC. Vlado, are you presenting yourself or should I present for you?
Well, Hannes, I think it will be easier if you just continue to share the
Okay,
slides.
then I
If
will
it's not
do.
a problem for you, thanks.
No, it's
Good.
just for me.
Okay.
Here we go. So
Good.
coming. You're sharing screen? Yes, I'm sharing. So here you go, Vlado.
Perfect. Thank you very much, Hannes. Good morning, everybody. It's Vlado Zettel from GRC. I will split this presentation in two parts. One will be given by me, and the second part by my colleague Simon. So basically, what we would like to present you in the next 10 minutes or so is the output or results of EU Gazetteer evaluation project, which was run over the last year. Next slide, please. So basically, the project was a kind of a continuation of the ELISE work. ELISE stands for an action which is run by GRC under the ISA Square program. So basically, as I said before, we started this evaluation project. There were several activities already regarding the Gazetteer, starting with the feasibility study, and then the Gazetteer survey, and finally a pilot definition, and all of that led basically to this EU Gazetteer evaluation project. In the project, we coordinated between two DGs, so basically GRC, but also Eurostat as a kind of a coordination board. And then we had our contractors led by Bilbo Matica. The project itself basically was split in several parts, as you see on this slide. One was the support to the EC, so to the Commission data acquisition. The second part was a cultural heritage testbed, and the third part, identification of different use cases. Next slide, please. Okay, let us go quickly through all these tasks or parts of the project. So in the support to the Commission data acquisition, so as it's written here, the main objective was basically to expand the range of authoritative gazetteer datasets which are available, to integrate with the existing data and technological environment, and to determine basically how to best use the new data available. Several tasks were executed during this, starting with data transformation, comparison, and data switching. If you just click Hannes, please, on the next slide. So you can see here, basically we were focused on 6 countries. And basically getting authoritative data from those 6 countries. It started with the Inspire Geo portal, but in some cases data unfortunately were not available there. So we were either contacting the public authorities or getting the data in a different way. It must be said that, yeah, as you see, the first task was data transformation. So basically, for each data set, the ETL process was developed by contractors. Basically, that to be able to transform data from, let's say, national data models into the nominatim data model, which is used on the Commission level and run by Eurostat. The second task was data comparison. So basically here we compared all this authoritative data with OpenStreetMap data, which are in the nominatim database. And finally, a kind of data switching. So basically the possibility to switch between these two data sources. Next slide, please. Here you can see some statistics, basically how many authoritative data we got, how many addresses, and how many from the OpenStreetMap, and kind of a ratio. Next slide, please. I think it is not so important. Here, just one example of the coverage by 1 kilometer grid as such. Next slide, please. Okay. Um, so during the data comparison, we did a lot of basically comparisons between OpenStreetMap and authoritative data. And here just some conclusions. I must say that we are working right now on the technical report, which hopefully we will publish later this month or in July. And the report will then contain all these comparisons on all the inputs, and it will be available on the Commission, on the GRC website. So basically, very quick conclusions on the comparison of these different data sets. So first, that authoritative addresses, they have a full spatial coverage of the country with high quality and completeness of the addresses. On the other hand, OpenStreetMap, we noticed better coverage in urban zones. We found out it's a more dynamic data, so because of the updates, yeah. And then, of course, it's community maintained, which is kind of advantage. But of course, getting into consideration both data sets, we can just conclude that they are really complementary data. Next slide, please. Okay, here I will hand over to my colleague Simon, who will then run you through the cultural heritage testbed and the use cases. Simon, please.
Thank you, Vlado. Can you hear me, everybody?
Yes, loud and clearly. Go ahead.
Perfect. So, as Vlado said, I will continue with the presentation on the two other activities run under this project. So, one was the development of so-called cultural heritage testbed, and the other one, the identifying of use cases. So to describe the first one, so the main objective of development of this cultural heritage testbed was to identify the gaps and the functionalities and the possibilities that already available European, pan-European gazetteers are offering, and how they are actually against the certain user requirement needs. For that, we took into the account the data sets from Eurogeographics, so the gazetteer services, the data by DG Eurostat, and the geonames.org. So please, next slide. To put this cultural heritage into the more context, maybe just explain that toponyms, as we are looking at it, can be, of course, presented in different languages. As you can see here, we have an example of Vienna in Austria, and it could be described in different languages in terms of so-called exonyms. In general, Europe, with its 24 official languages, is quite rich on as well the naming and describing the geographical names and places. And so the exonyms are quite rich in Europe. So the other case is, for example, when we compare different languages, so the same toponyms in different languages, so-called exonyms, may describe different objects. So we have here example of the name Dunaj, which in two different languages represents two different toponyms. So one in Slovenian, that means Vienna as a city. In Slovakian, that means the river as a Danube. One other, let's say, important fact is as well that name changes over the time, so especially in some parts of Europe. And so that's also one of the potential, let's say, condition that we took into the consideration in the development of the cultural heritage testbed. Maybe just to put the terms cultural heritage into the right context and understanding. So we are here talking about the place name as a cultural heritage of Europe, and not of the cultural heritage protected site inspired team. So we are actually here dealing with the gazetteer data sets. Next slide, please. So when how we dealt with this cultural heritage testbed. So there were different tasks, user requirement specification. For those, we invited some external requirements definition group, which was according to the previously described from the historians. So there were comparison analysis made on these three existing gazetteer models, and open source testbed application has been developed to do some testing. On the next slide, you can see the example of this application in which it was different functionality available, like a search option, map viewers, some reporting tables, and scoring sections for the results of the test. So we won't go here into the details as Vlado mentioned. So further findings will be published in the technical report, which will be published during the summer. So to touch also the next activity, next slide please, which was more, let's say, towards the use cases. Our intention was to identify different use cases in Europe with also, let's say, potential need of pan-European gazetteer services. So we tried to orient to the pan-European transnational cross-border examples, with which we did, let's say, various of interviews. So on the next slide, we described roughly few of the use cases we've been discussing with. So the first one was from the Le Grand Region, actually. So it's the between Belgium, Germany, France, and Luxembourg. They're providing GIS system of this region. So this was actually initiated by the EU-funded Interreg project. And after the project has finished, the partner decided to use their own public funds to ensure the continuation of the project. The next one is also coming out from the Interreg 3 project, coming from Central Europe, between Austria, Czechia, Hungary, and Slovakia. Centrope map statistic is actually kind of a cross-border information system supported by the Austrian Planning Association, which enables planners, decision makers, researchers interested overview of the, let's say, map overview of the Centrope region. Next slide, please. So the following case was on the locator, so offering the business information for enterprises between Belgium, Germany, and Netherlands. So it's a kind of a multi-purpose system supporting different functionalities, and user can actually obtain information about the available plots of business park, existing companies, availabilities of commercial real estates, and information about the settlement condition. Last but not least, the case is presented by the public enterprise by Danish Ministry of Climate and Energy, providing interactive map on energy production, consumption, and import from and to Denmark. So they are divided into different maps showing electricity and gas. So on the next slide, we are speaking also one interesting use case or scenario of European citizens, which is in one of the member states applying for the fiscal number when he or she is moving. So this fiscal number could be provided by two different authorities, and the calculation based is also based on the information about the country of the birth of the applicant. As we know, at the end of the last century, the countries and the borders a bit changed, in particular in the Central and Southeastern Europe. So let's assume that the applicant is born before 1990 on the territory of the country that is emerged after 1990. So visiting one authority which used the latest status of the data and another authority which is using historical data, the outcome is that all these two authorities are actually issuing two different fiscal numbers to the applicant. So at the end, applicant is not uniquely identified with fiscal numbers and could lead him with some problems with the authorities. So let's finalize on the next slide a bit of conclusion of those two activities. Generally, if we see speaking of the use cases interviewed, so in cross-border regions project initiatives, whatever we can name it, because there are different forms. We have so the partners of different countries, so we're accessing, let's say, different kinds of data and services, so whether authoritative, commercial, or voluntary. And most likely, in most cases, it was under different licensing condition, and in most of the cases, even not harmonized. In some cases, they relied also on data acquisition processes. So generally, as a feedback, there was expressed the need of the different gazetteer data themes, European gazetteer data themes or services available, openly available. So for example, addresses, administrative units, geographical names, buildings, and infrastructure. So they were somehow emphasized, and to be harmonized and with clear conditions of use. Important element was multilinguality as well. And in some cases, also historical component of datasets would be required. So in general, common EU gazetteer data service would be appreciated, offering detailed information on addresses in the first site, offering buildings, information about the buildings and their functions, for example, the hospital, gas stations, police station, and so on. Also offering the information about the infrastructure for planning and emergency management, for example, in the earthquakes, floods, and so on. For the tourism purposes as well, like a point of interest, but geographical names, in particular, supported by the multilingual component. And last but not least, all these cases so far are not so much relying on opportunities the APIs are offering, but the most of them actually stated that in the near future, if there will be any APIs available, they will adopt their information systems towards that. So that would be from my side, as mentioned already by Vlado and also by me. So the more details, let's say, findings will be published in the technical report. And follow us on the Elise join-up page where we will publish the reports and you will be informed about it. Thank you very much.
Thank you both for this presentation. I have one question for you from the chat, from Markus Jobst from Austria. He asked you on cultural heritage, and he asked if it comes to sustainable usage of spatial data, especially for CH, I assume you mean Switzerland, Markus, the semantics, ontologies, and controlled vocabularies become important. How did you consider the domain-specific semantics in the use case evaluation? E.g. the work of pelagius.org. Cultural heritage, sorry, not, yeah, okay. Are you aware of the work from Pelagius?
No, we were not aware of that work.
Okay. Thank you, Markus, for that comment then. Maybe this is something what we can take into account for that final report on that work. If there's no more questions in the chat, I'll leave for 1 second there. No one raising the hand, because today I'm the timekeeper and I'm not really good at that one, I must admit. We are done with 3 presentations and we are already at 1 hour, so we need to hurry up a little bit. So I'm stopping that one now here, and we'll hand over to the next presentation. Sorry, to Peter Brestas. Peter, should I present as well for you?
Yes, please.
Okay, here you go. Do you see the presentation?
Not yet.
Oh, sorry.
You can skip the first slide already.
Yes. Here. Sorry, my fault. Boom. Share screen. Here we go. Good. Now you should see the screen.
Yeah, thank you, Hannes.
And thank you for coming over.
Yep. Okay, my name is Peter Bresters. I am working for Statistics Netherlands, and I am contact person for and responsible for Inspire and our applications in that field. And I have been thinking a lot about how to deal with the teams, population distribution, and human health. Because these teams don't have geometry in their data model, and that makes it complicated. So please, next slide. Therefore, we first thought that we could deal with this with a so-called table joining service. This service would join the tables from the team's population distribution and human health with the geoservices for statistical units and create maps, and then in an automatic way. Next slide, please. And this is what was happening then. Yeah, so it would be automated. But we found out that this was not the best way to go after all, and I will explain why it was not. So we thought of an alternative approach, and well, I will show you how we did this. And finally, I will come up with some conclusions. Next slide, please. So why is the table joining service not so suitable for Inspire? Next slide, please. We had mainly two reasons why we decided not to use the table joining service for Inspire. Many of you will be confused because I have been promoting the table joining service for years, and now I come up with a reason for not using it for Inspire. So I will try to explain. First, the Inspire specifications are far too complicated to be dealt with in a table joining service. It wants us to have metadata on services, on the data set, and they need to be linked to each other. Secondly, well, that's the reference to the metadata of the data sets, for instance. But we also need to provide certain performance and monitoring of these services. And well, we found out that if we wanted to fulfill all these Inspire specifications, it would be too complicated and too expensive. Although we already had a working version, it would just be too complicated to get it working according to Inspire. Secondly, there was no fit with the business model of the hosting organization. The hosting organization thought, well, the table joining service provides us temporary services, but Inspire needs permanent services. Otherwise, you can't have all these links to it. And so there we had a conflict. Because if we wanted permanent services coming out of a table joining service, the hosting service would still need money for that. And they then it would need tedious tender processes. So that would take away the total flexibility and advantage of the table joining service. So those were the main two reasons why we did not use or decide not to use the table joining service for this anymore. I must say this does not mean we do not want the table joining service to become a real thing. It still has advantages for many users, I think, but not for Inspire because, well, the reasons I explained. Next slide, please. So we came up with an alternative approach. Next slide, please. This approach basically is based on 4 steps. So first we convert to SDMX data, and From that, we convert to a comma separated file. We join this file to a GIS, in a GIS to statistical units, and then we create metadata, the data set, and create Inspire services. I will talk on these four separately. Please, next slide. So first, the conversion to SDMX. This is actually only needed if the data is not already available as SDMX files, like in the Eurostat SDMX services. But if it was not there and we still thought it would be necessary to publish, we decided to use the same data structure definition that was used in the Geostat 3 project, which is, by the way, not yet official. And we used the SDMX converter, which everybody can download from the Eurostat website. And we converted first the data into SDMX. In the next step, we converted the SDMX files again to CSV to be able to join it to statistical units. Next slide, please. So this is how the user interface of this SDMX converter looks like. It can both convert from several file types to SDMX as from SDMX to several file types. And we used CSV. So then we started to join this CSV to the statistical units. You can do this easily in ArcGIS or QGIS. We loaded the statistical units, which we already harmonized. So the geographical part is already harmonized. And we load the CSV from the previous step. And then we perform the join operation. The final result is saved as a shapefile and as a geopackage, which becomes more and more a standard. Next slide, please. And as you see, here is a result of joining from the Dutch communities to the total population, and then you can get a better style using the symbology options. Next slide, please. So you can make a map like this one. Next slide, please. So then we created metadata in our national registry for all our Inspire datasets, as we do for all our Inspire datasets. And here we come up with the link to the SDMX files at the Eurostat service, as you see, or at our own service if it's needed. Next slide, please. Then we create inspired services. So we ask our hosting organizations to create these services on the basis of the GIS files that we created in the previous steps. And they create an atom feed to the SDMX files. So that is the Inspire download. We create a WMS, which is the view service on the basis of the GIS file. And we do something extra. We do create a WFS from the GIS file, but we don't say this is an Inspire service because, as we understood, you cannot both have a WFS Inspire service and an atom feed. So we only make the atom feed Inspire compliant and the WFS just with the application profile other. Then finally we made metadata for the services. Next slide, please. So I come to my conclusions. Inspire is too complicated for the table joining service and does not fit the temporary TES approach. So we came up with an alternative. Just to create an atom feed to the SDMX files, and to create a WMS on the basis of a join of this SDMX file to or CSV to statistical units. And to make this more official according to Inspire, we need also an official Inspire data structure definition file for SDMX, where the themes population, distribution, and human health. Thank you for listening. We have some questions, maybe?
Thank you, Peter. It's Vlado speaking. Do you want me to run Slido for you?
Yes.
Okay, just a second. I need to share my screen.
I see already a question.
Okay, so for everybody, please join us at slido.com. Inspire
first read
2020
slido.com.
is the hash tag. I will just start with the first poll, and then you also need to choose the right room, which is statistics, geospatial. Okay, I will run the first poll, so you can, let's see how it will work.
So the question is, what is the procedure to get to a final definitive SDMX DSD? With one answer.
And maybe before we let everybody, let everybody a little bit voting time here on that one. And before we go further, Peter, you have questions in the chat. What
Yes.
was from Geraldine from Belgium? What was the metadata standard you used to describe the metadata of your statistical data sets? The ISO Inspire ones. And then a second question from Martin Tuchuni. Peter, you asked before the conversion to STMX or CSV, how did you execute transformation towards the Inspire data specs? Maybe you can answer that one, and we let everyone, because we have 97 people in the call and we have only 7 voted, so we let everyone go to Slido and do their voting there.
Okay. The first question was what metadata standard we use. We use the Inspire metadata standard. So it's all compliant to Inspire. And the second question was, how do we convert? Well, we converted to SDMX on the basis of the same data structure definition file that was used in the Geostat 3 project. Eurostat has come up with a not yet official, but very well working structure file. This was created during the Geostat 3 project to show that you could transform the census data based on 1 kilometer grids into Inspire conform data. And so that's the same structure file that we used, and you can use this one in this converter that I showed.
Thank you, Peter. Any other questions from the floor? Let me just see if someone has raised a hand. No, I don't see anyone. Maybe, Vlado, do we move to the second question?
Yes.
Or we're commenting? So, yeah, what we see here from the...
Sorry, I already moved to the next one.
Fine. So thank you, Peter, for your answers, also from Martin and Geraldine. So here comes the second question. Peter, you want to give a little bit background on the question?
Yes. Actually, I was part of the team that created the data specifications for population distribution and human health. That was in the year 2012, so it's a long time ago. And but what I do remember is that we were not allowed to put in the data specifications what data you had to provide. The reason was that all member states should provide what they have. But already at that stage, I thought that was not a right approach, because the amount and the type of data that we have in the different member states is so different. So you get, if you just don't decide on what data should be published, you will never get harmonized data for cross-border mapping purposes, which was actually the main goal of Inspire, as I understood. So this harmonization on what data, so what regions, for what regions, what attributes, what periods, there was no decision on that. And I think that was something missing in the Inspire data specification. So who should decide what data, at what geometry level, for what periods and what attributes we should provide Inspire data?
Okay, thank you, Peter. I think it's a clear outcome. We have over 92 90%, 86. Now it's changing. We are raising up. Maybe Vlado will leave the poll a little bit more open for a couple of minutes, and then you can vote for the end. And as we are, there's a third question.
Yep.
This is for me. Okay, this is we leave open. This comes after my presentation.
Okay.
And because we need to rush a little bit, we are a little bit late. And today I'm a bad timekeeper. I'm following Yuri here. We have our African feeling here. Wait a second, share my screen again.
Just a second.
I could get the screen back, please, Vlado.
Yes, you should be able now.
Yes,
Go ahead,
I am.
Hannes. Yeah.
Thank you. And I will try to hurry up. Having said that one, can you see my slides?
Yes, we can see it.
Okay, thank you. And I start my video to be also a nice host to you. So I hope that. So why the next presentation is why we have brought it into this game here, or this today's presentations, is because we want to make publicity for that one. We want to ask you for contributions, and because we want to propose it. Title is SDMix as a good practice for statistical data sharing under Inspire. You see Vlado here, Peter, who just have spoken, and Miroslav Migas, who is a coordinator from statistical cluster under Inspire. So saying that one, what is the objective? We want to promote SDMix as a good practice for human health and population data dissemination under Inspire. This has advantage. Why do we want to use SDMix for that one? Because our statistical data in our statistical world is usually already in a structured, stored in a structured way. We even have the code lists in dedicated registries, and we don't need to reformat that one. So we avoid duplication, synchronization issues across data sets, and we allow for machine readable data. So for the people who have no idea what is SDMix, it's an ISO standard and is designed to describe statistical data and metadata. It has 3 components: an information model, a standard for automated communication, and third, which I personally also find interesting, is an IT architecture and a set of tools and data and metadata exchange. So why are we also interested in that one? Because we will be in the future disseminate for the Census 21 grid-based statistics according to Inspire. So for example, here you see all the statistics which are coming on the 1 kilometer grid. For the 2011 grid, 2011 grid, we just had the total population. What is here? 6.0, if you can see it on the screen. Now we have a couple of more columns which we need to disseminate on that one. So having said that one, where's Eurostat involvement in SDMix? We are one of the sponsors and users. We also implement and use tools to support SDMix data, and we will be, as said already, responsible for the census regulation on population. So, and we have already shown that this is Census Grid is an important pilot for the integration of statistical and geospatial information. So what is our proposal for the MIC for endorsement? And you are more than welcome to comment still on the Inspire platform to do so. We have documented several reference implementation at various organizations. There are commercial and open source implementations available. Several statistical offices in various European Union member states use it already in production for data dissemination. So we have seen examples in Oskari for Finland, in Stage for Slovenia, and even the GeoServer table join service Netherlands, or what we just have seen now, the SDMX directly. And what we would like to encourage you all that you come up to the Inspire cluster for comments. And with that one, I just had prepared a couple from the member states examples, but for that one, I keep that for the day, for another day. And thank you very much for your attention. And I'm open to hear any questions from you. Let's see in the chat. Sorry, I need to stop sharing my screen. So Marcus, yes, okay. Marcus, do you want to speak open up with a mic, maybe quicker than typing it in? Yes, and thank you, Vlado, for putting up that on the slide. Well, Marcus, I have no idea. I'm too young in the business. I'm still too young. Maybe one of the old timers, Peter or someone else, needs to answer that question. Peter, do you have a question? Why it has not been considered in Inspire in 2002?
Yes. We well, we tried to discuss this with Eurostat, but at that moment we could not come up with an agreement on how to get the geocoding into SDMX. So that was one of the problems, and well, we did put it as an alternative encoding, but not yet as an official one. So we did think about it, but we did not come as far as we are now.
Thank you, Peter. And then on the question from Juri Robrecht, will you propose SDMX encoding as a good Inspire practice? Yeah, that's the idea behind the document. We have published it for consultation on the Inspire cluster. So member states could contribute at that one. And we have drafted a document there as a good practice document. And here we see that 64. So some people say no, some people say maybe. We consider that one as a good practice document. So, and Geraldine, do you foresee the mapping of SDMX into could be done? Sorry, Geraldine, I cannot. I recall there was some discussion, and I don't know anymore. So my memory is failing me. There was something to decard SDMX decard. There was something ongoing, but my memory is failing. And before something is saying wrong, I will stop telling anything. With that one, we leave that. Yes, maybe too complex for now. Exactly. We park the discussion for another day. With that one, thank you all for listening to me, and we hand over to our last discussion for today. Vlado, could you put the presenter now to Kati? Because she's our last presenter and would like to present herself. Kati, are you still with us?
I am here. I'm waiting. Okay, now I can share content. Now I need to find the right screen. Okay. You should now be seeing my screen. Does that work?
Yes, super. Thank you. Go ahead.
Okay, so this is a bit coming in from the total edge. These are demography things which have, let's say it's a very novel way of doing Inspire differently, but still being compliant. Okay, background of this is coming out of the API for Inspire project. And there we've been exploring, there are two new APIs coming out of OGC, which are making it far easier to access data. So these are replacements to our known and loved web feature service, web map services. The two APIs we're evaluating are the OGC API features and the OGC Sensor Things API. And within this project is funded by the European Commission via the ELISE action and coordinated by JRC. So we've set up an evaluation methodology to figure out, do these APIs work for us? We're deploying various endpoints of both the OGC API features and Sensor Things API. We're exploring the usability of these APIs. We're collecting feedback on how easy or difficult are they to deploy and to use. All further details in our webinar on Thursday afternoon. A short overview of the project partners and data providers. So the project itself, the lead is Fraunhofer EOSB in Germany. Then there's Data Cove, which is my organization, and GeoSolutions. And we have a whole set of associated data providers who are making their data available, collaborating with us, trying to deploy these API endpoints and providing feedback. How was it? So where did we start? We started out with what we're calling our hydro things. This is the Sensor Things API, making various water-related data available from France and from southern Germany. It's a nice cross-border example, and we've got surface water, groundwater, quality, quantity, what you can measure on water. We've got all our little stations. Everything was cool. And then COVID came up, and I started catching all of the connections with air quality. And one of my way back backgrounds, I did the European air quality reporting. I know where all the data is, and I was locked up, I was bored, and thus we ended up having air things. This started out as a little ad hoc thing just for Austria, and the more feedback we were getting from other member states saying, could we also have this? We then actually access the data source at the EEA. It's not easy to find. It's not easy to interpret. It's now all online in real time. So this was getting pretty cool. And then I got a very interesting thing in from a student at the Technical University in Stuttgart, that he had actually put COVID things online. He's accessing various COVID data sources, the Johns Hopkins repository, German data from the Robert Koch Institute, pulling all of that together, again, making it available for all the spatial objects he can find. So in this case, the hydro and air things were all point-based sources where we really have monitoring stations. The COVID things are now on a national or regional level, providing the number of ill, sick, died, recovered. And that was very interesting. We could now compare the air quality with the number of COVID cases, but what we were missing as a background layer is the demography. The number of cases makes no sense if you don't know what is the background population. And I know what all is available at Eurostat. I've played with this source over the years again and again, but it's so hard to access in a spatially integrated manner. And so a few weeks ago, I had a long weekend. I was a little bit bored. And now we have demography things. So I've taken the European demography data from Eurostat, put it online via the Sensor Things API, and we now have all of this available in a nice spatial manner. A few details on the technology. The Sensor Things API I've been telling you about, it comes less from the OGC world, more from the Internet of Things world. We're getting all of these great sensors out there. They're producing data. How can we make this available? So a group with an OGC set up the standard. It's been an OGC standard since the end of 2015, beginning 2016. It's a beautiful, simple API approach for providing sensor data, whereby don't get scared by the sensor. You don't need a sensor. It's basically a beautiful way of providing data on spatial objects over time. It uses JSON encoding, so it's very easy to use, to understand, to code applications using it. It's a well-established standard, so we've got various stable implementations available, also open source. And it's been under evaluation for a while now as an inspired good practice. So we've, on the data level, we've done the mapping to the environmental monitoring facilities. That's all nailed down. We've got the DOI with presentation there. And we're in the process of finalizing an inspired good practice. Now, going off from this to the demography things I set up, as I stated, the data was stolen from Eurostat. It's right now, it's population and population density, no problem adding all of the other metrics you have on NUTS regions. I had the NUTS regions I already had in my databases, so that was put online for NUTS levels 0 to 3. The statistical data was linked to that. I also have methodological information backlinking then to the Eurostat references. And the other cool thing is that we can expose this with GeoJSON, which you can directly throw at a map. So here, now to scare you a little bit, this would be the URL request to give you the population in all European countries. The trick is, you see at the top, the bit with the length name equals 2. There I use the trick of the hierarchy of the NUTS codes. All 2-level NUTS codes are countries. So I take two-letter codes, I've got countries. I'm taking the observed property that the demo RPGen agra is from Eurostat. I'm assuming you understand that better than I do. And the final interesting thing is the result format GeoJSON at the bottom. And if you put out this request, you get very nice, simple GeoJSON as a response. And the cool thing about this is you can take this data file as is and go to any GeoJSON viewer. I've selected geojson.io. And you paste it in, and you have your data on the map. You can click on the countries, you get your attributes. The little box I put in the middle is for Austria. So the population of Austria is 8.8 million. Conclusions from what I've seen, SensorThings API could be a very interesting alternative for the provision of spatial data pertaining to statistics. It is exceedingly easy to do. I mean, this was 2 nights over a weekend, and my major issues were issues with the Eurostat CSV and TSV files. And the Frost server is extremely flexible. So, and what I really like is the option of accessing this data as GeoJSON, which is a well-established format which people can really use and integrate. That's it. Thank you. Questions?
Thank you, Kati, for this nice presentation. I think now we have walked everything. We leave the chat open for a second to give everyone time to type it in. I think now we have walked the whole, let's say, the session from an political UNGGM down to some URL $character questions now to a nice end. Marcos really likes your examples. Other comments from the audience, please? Seems that everybody is really impressed.
Okay, the endpoints are available, and if you want more information, join us on Thursday.
Okay. Kati, the Frost server, is that an OGC reference implementation already?
That's the OGC reference implementation, and it's done by Fraunhofer EOSB. If you want details, Hilke van den Schaaf, who's the developer, is actually online here. It's been taken up more and more around the world, and I must say I'm in love with Frosty.
And Kati, there's a question from Martin Turina. Sorry, Martin, I cannot still not pronounce your surname correctly. Turina. Is this a possibility to use data already provided by the member states and publish them with approach you presented, meeting Inspire requirements?
That should be easily possible.
Okay.
Come out and get in touch with me. And our borders are finally open. We can meet in Bratislava.
Okay. Okay, good. Anyone else? Any questions? Let me see if someone has raised a hand. We have now over 103 people in the room, so it's a little bit of scrolling for me here, going up and down. No one has raised a hand. Any further questions you would like to put up for discussion? We're listening to you.
And one further question from my side is, I just got the question of, could we add hospital data? I've wanted to, and I've run into such issues with your download formats.
With our download?
There is just all these little details, be it quotes in the quoted strings, be it that there is a comma to separate the thousands into numbers. It's not fun. Okay.
With the GeoJSON, maybe you email me on. I assume you use the GeoJSON directly.
If you have a GeoJSON access, that would be great. I mean,
so the GeoJSON is there.
I'm taking the TSV or CSV files from your database explorer.
Here, Kati, here's the GeoJSON. Directly from all the hospitals.
Perfect.
Okay.
We'll get that shortly. And anything else you can throw at me in that.
And sorry, Kati, on your comments on the TSV and CSV and Eurostat official dissemination, I will and cannot comment further on that one. This is statistical world for the moment, and maybe we need to do something on that one, but that's outside my hands, and people have written all the algorithms surrounding that one in production, so no further comment from that one.
Okay, the endpoint you gave me will also have other things, I'm assuming. But the
endpoint I gave to you now has the hospitals. Maybe I show the hospitals, the number of beds, and URL, latitude, longitude, and all these kind of things. If I share my screen again, but I cannot because
let me unshare. How do I unshare? Stop sharing.
Yes. Vlado, could you give me share? Yes, thank you. So, judge. You see, this is a data set which we have here. It's still work in progress. And for each little hospital, little dot here, you have something like an ID, a name, a site, latitude, longitude, the street, the house number, reference date, publication date, and depending on the country, we might have a little bit more information, because this is drawn up or a merged data set from national ministries in response to the COVID-19 crisis. So we have put a little bit effort in here, and then you see, depending on the country, we have more information, or we have also the number of beds for certain countries. And this is a work in progress where we have sourced the data sets directly from the member states. And this is just the number of beds.
Why aren't you putting this online as Inspire?
This is has nothing to do with Inspire for the moment.
Why not?
Yeah, for sure we need to do in the future, but then we also need to do everything according to the Inspire specifications, which we have not done so yet.
Let's see where they go. Okay, thank you.
Okay, so any more questions from the audience? If not, then let me all thank you for attendance this morning. I think we had a nice view over quite a variety of themes, starting from UNGTM Europe, over poverty from Austria, ELISE and STMX issues, down to API thingies from Kati now. So thank you all for attendance this morning, and I wish you a nice day, and please please contact us, any of the authors, if you have further questions. Thank you. Have a nice day. Bye-bye.
Bye.
Bye to everybody.
Bye.